Hello, this is a video for any of you who are thinking of taking S283, the Open University's module Planetary Science and the Search for Life. I'm Dave Rothery, I'm the module team chairman. I'm Professor of Planetary Geosciences here at the Open University, and I'm just going to tell you a little bit about the course, or module I'm meant to say these days, and introduce you to the module team. Okay, well, S283 has 2 books. We still use books on this course. I know some of you love books and some of you might rather have things online. Well, we do have online versions as well, as I'll show you. So let's have a look at the books. Okay, first one is called Introduction to the Solar System. The second one is an Introduction to Astrobiology. And they do what they say. You study these courses over a period which starts first week in October, more or less, and we have the exam in June. These books are new editions that are dated 2011, so they're not that old. The first chapter introduces you to the solar system. It's a whistle-stop tour through all the bodies, including Pluto on this page. Now, we're getting very excited about Pluto. I'm recording this on the last day of June 2015, and on the 14th of July we get the first ever flyby of Pluto, which isn't a planet anymore, quite rightly, and its major moon Saturn. They're going to be fascinating bodies, so it's always a great time in planetary science. The second chapter is about the internal structure of the terrestrial planets. If you've done any geology, plate tectonics works will be quite familiar to you. Internal structures of other bodies, Io and Europa, 2 moons of Jupiter. Then we get on to processes like planetary volcanism, quite a lot of it on the Earth of course, but other bodies as well, lava flows on the Moon, volcanoes on Venus, explosive eruptive vents on Mercury even, Mars of course, icy volcanism. We then go on to start looking at the processes of impact cratering, which give a lot of information about solar system history. Then we do atmospheres of terrestrial planets, how you determine compositions of atmospheres and so on, and the temperature distribution with height in an atmosphere, stratospheres and planets without stratospheres and so on. We then go on to look at the giant planets, Jupiter, Saturn, Uranus and Neptune, how we've studied them, their magnetic fields and so on. We're going to look at minor bodies, asteroids and comets. Cloud belt objects like Pluto. Then we look at the origin of the solar system, because by this stage we know what the solar system consists of, because we've taken you through it. And then we have something about meteorites. They're the most primitive material, some of them are at least, and they can tell us how the solar system formed. And of course some have organic molecules in, which kind of leads on to the second book, Introduction to Astrobiology. It's the same length as the first one. So there's a little bit of biochemistry there. Mirror images of molecules, that's a process called chirality, how cells might have occurred, the last common ancestor of life, habitable zones, what it takes for a planetary body to be habitable. But we're talking about microbes here, not little green men, by and large, extremophile organisms like these little green things just below the surface of a rock. Then we look at Mars, because that's a habitable planet. There's layers of ice below the surface. We've got rovers wandering around on the surface, finding these little nodules deposited from solution in water and so on. So Mars is a really exciting place. We also look at icy bodies, in particular Europa. Come on, Europa, which has an ocean below the surface, we think, almost certainly. How we've studied Europa, and in what ways it could be habitable, where life might occur below the surface, or even temporarily exposed where the cracks open tidally. We have a quick look at Enceladus as well. Then there's a chapter about Titan, the moon of Saturn, which has a dense atmosphere, the only dense atmosphere around the moon anywhere in the solar system. And the OU was instrumental in landing the Huygens lander on Titan 10 years ago. So we'll talk about the surface properties of Titan, we'll talk about the lakes and so on. Then we go on to exoplanets, how exoplanets are detected. It's either by a planet going in front of a star and dimming its light fractionally, or it's the orbit of the planet just jiggling the star side to side slightly. So if you're an astronomer, a lot of this will be familiar to you. And then we detection methods for exoplanets. Then we finish off by looking at extraterrestrial intelligence. Here's Carl Sagan, as some of you may remember. So I think it's a fascinating course. Now, if you're studying astronomy or a physics pathway, it's a good course to take. If you're doing geology, I think it's a good course to take. I mean, I'm a geologist myself. I think if you're wanting to know how the Earth functions as a planet, you're pretty daft not to consider how other planets function as well. So it's a course that suits astronomers or geologists equally well, provided you can find other level 2 courses to complete your level 2 study, because you need 120 credits at level 2. This is just a 30 credit course. So let me show you how you work your way through the course. So here's the forum on the screen. This is the it says study planner there. You can see it week by week, and this really will take you through the course. Everything you need is here. You're told what you need to be doing each week and so on. Things that some people have trouble finding are the assessment resources. So over here, assessment resources, click on that. You get advice about plagiarism, warning you about it. Here's TMA1, TMA2, TMA3, TMA4. Let's just open TMA1, tutor marked assignment 1. You can see it question by question, or you can see it all at once. These TMAs are a very useful thing to do. You'll get feedback from your tutor if you attempt a TMA. All you need to do is score over 40% of the marks available in order to get a passport to the exam. Once you've exceeded your 40% threshold, you can take the exam at the end of the year, and your TMA mark doesn't count any further beyond that. But we do encourage you to seriously attempt the TMA questions, because we find the feedback that you get helps you, and people who do better in the TMAs do better in the exams. There's also an exam at the end of the year, and we have a specimen exam paper. Here I am, click on that, you'll see the specimen exam paper. So this is an example of the kind of paper you will get in the exam. Part of it's computer marked, that's worth 28% of the total, and then there are questions. Part 2 is for 4 questions, you answer 3 of them. They're essentially about the first book I showed you, so you choose 3 out of 4 long answer questions there. And part 3 is you choose 3 out of 4 questions basically from the second book. Now, the exam isn't meant to be a memory test. Its main purpose is for you to show us that you've understood processes, and if we give you some data, you can make sense of it. We do need to know some basic stuff. How far is it to Jupiter? Jupiter's 5 times the Earth-Sun distance away from the Sun. Neptune's 30 times further from the Sun than the Earth. Basic facts like that we expect you to know, but detailed facts, detailed formulae will provide you, but you need to make sense of them. But you can have a look at the specimen paper. Right, I'm going to now introduce you to the course team, show you around the place a little bit. Today is a special day because today the exam award board is meeting. So we've marked the exam for the students who started in October 2014, and we're deciding the grade that every student gets today. It's quite a big job, so we'll be doing that today, but it's a chance because everybody's in. I'll introduce you to the people. Okay, let's go and see who's around. Why don't I show you my office first of all? You've seen a bit of it. It's a bit of a mess. Oh, yeah. If you're looking for something to do before you start the course, you could do worse and read this book, Very Short Introduction to Planets by me. It's $7.99 or something from Oxford University Press. Very cheap, handy little book. But everything you need to pass the course is in the course. So if you want that book, it's a good read, a light start. But of course you don't need to. So I'm quite lucky to have an office these days. It's quite a cramped little room. I work on the planet Mercury. I'm involved in the European Space Agency mission to Mercury. Here's a it's not the moon, it's a mosaic of Mercury. It's quite a heavily cratered body, but there's some quite smooth areas. This area here, smooth plains. It's been flooded by lavas, and there are some bit small to spot. But here, for example, this feature is not an impact crater. That's a volcanic vent. The thing just there, these are impact craters. That's a volcanic vent. So there's been some explosive volcanism as well as some lava volcanism on Mercury. I'm going into the room where the students are. It's 9:20. Oh, there's a few of them here. So, Rian, you're working on Mars, aren't you?
I am,
Tell the
yes.
students what you're doing.
I am modelling dust storms in the atmosphere of Mars.
Dust storms in the atmosphere, okay. Go on, Jason, what are you doing?
Study glacial and periglacial environments on Mars.
Right. 2 Mars people. Becca, what do you do?
I'm a Mercury girl. I look at explosive volcanism and little structures called hollows in the surface of Mercury.
Thanks, Becca, because Becca's one of the witches of Mercury, it says here. Okay, catch you later. Right, now I'm looking for the newest member of our course team, Suzanne Spencer. Is Suzanne here? Hi Suzanne, I warned you about this.
Hello.
Please say hello to the S283 students and tell them who you are.
Hello, good morning everybody. I am Susanne Schwenzer. You might hear my accent. I'm from Germany and I studied Earth Sciences in Germany. I then went on to get a PhD and I measured noble gases in Martian meteorites. By the way, I might even have one for you. Let me see. Yes.
Ah, you're going to brand this a piece of Mars.
Here it is. This is a piece of Mars.
Close.
And if you get close, you can read that it is 6234. 6234 is a Shergotite, and we are looking in this for a tiny little shock wave. That is when a rock gets slammed by another rock, and then you get little black veins. And you'll learn all of this, by the way, in the S283 course.
We're zooming in on this bit of Mars for you. Where do we think this rock came from, Susanna?
It's NWA, Northwest Africa, so it's collected by the Bedouins in Northwest Africa and then sold to a dealer where we got it from.
But we think it came from what kind of place on Mars?
Well, it's a Shergotite, so it's a young volcanic rock, so it could be from anywhere except where the rocks are very old. So one of the volcanic provinces, maybe?
You've got a Lego toy.
Yes.
Tell us about your Lego toy.
Well, that Lego toy is Curiosity. And if you look at it, it's got a mast with a camera and that has a little red dot. That little red dot is actually the laser with which we can analyze rocks, and it has got an arm which it can drill rocks with. I mean, if you want to see this, I can show you the back of my screen where we have an actual drill hole that Curiosity did. So this is how it looks when we drill on Mars, and what you see there might surprise you actually, because we know Mars as the red planet, but once you drill and that drill hole is about 2 centimeters deep, Mars gets gray, and that is very exciting because it means it is not as harsh and oxidizing just 2 centimeters down. So this is one of the findings that Curiosity did on Mars, which is very exciting if we are looking for past habitability of Mars and want to find organics on Mars.
You spent some time driving, not the Lego version, but the real version, don't you?
Yes, I'm actually on the MSL science team. I am not driving the rover, that's for the engineers. But what we do is we make decisions where the rover goes as a team. Now imagine we are over 470 people who do this and who do this in shifts, and we make decisions where to go, what to analyze, and when the data come back, we are analyzing those data. And one of the best findings in terms of noble gases is a paper that you can find in Science by Ken Farley, where they actually took these drilled rocks that I've shown you on the screen and did age dating with them and found the old age that we would expect for the Gale crater in these rocks. But they also could find out how long this surface was actually a surface and how long it was buried. So that is called exposure ages. And these exposure ages are very exciting because they are young, which means this area was buried for a long, long time by other rocks. And so something that would have been there, say some organics that would have been there, are much more likely to be preserved than if you have an area that has been exposed to the harsh environment for a very long time.
That's very exciting. Thank you.
Welcome.
I'll see if I can introduce you to a couple of important people through here. This is where curriculum support goes on. And here's our curriculum manager, Jenny.
Good morning, Dave.
Good morning, S283 students for next year.
Yes, good morning to all of you as well.
Jenny, you don't just work on 283, what other courses might students meet you on?
They might meet me on S295, which is the biology of survival, and they might meet me on S369, which is the geological record of environmental change.
Biology of survival's a 30-pointer, yeah?
Yes.
So can be studied alongside 283
Yeah,
and
they would
the
go together quite
60-point
nicely.
Earth Science course to make up a nice level 2.
Yeah, absolutely.
Okay, thank you.
Thank you, bye-bye.
And the other important person is our curriculum assistant, Ashaya. Morning, Ashaya.
Hi, Dave.
Hi, we're doing the usual video for the new students.
Welcome, students, to S283.
Tell us what you do.
Oh. I look up to Dave doing his. I do the styling of the chapters and the temas.
And the exam paper.
Exam paper.
Yeah.
Try and help the students. And whenever you need any help, please come to us.
Thanks, Ashaya.
Thank you.
So we're waiting for the external examiner to arrive, but I found one more member of the course team.
Hello,
Here's
everyone.
Mahesh Anand.
Hello.
Mahesh, what are you doing in terms of planetary science?
Well, I work on lunar samples. My interest is in understanding how the moon formed, and more recently I've been interested in researching on water in the moon. That's a hot topic. It's a bit paradoxical, but yes, I'm very excited about new findings, and also I have interest in understanding the inner solar system. So I look at Martian meteorites and different types of meteorites that tell us about how the solar system formed and how it evolved over time.
Okay. And who do you think is going to win the Ashes, which is starting in a week or two's time?
Well, I think there is a little bit of hint there already. The weather is all fine, you know. So yeah, bring it on.
Well, it's 5 o'clock now. We've had a very long exam board meeting, but we've adjudicated all the results. I forgot to video the external examiner before he left, so you won't get to meet him on this video. And there's one academic member of the team not in today, so he's missing as well. But what I forgot to mention to you, well, I didn't mention the study time required on this course. It's about 300 hours of study, so that's about 10 hours a week you need to find on average from October till June. A standard 30 credit course, as well as the books. There are a few videos and other activities. They're all available online. And I didn't really talk about the forum, so let's have a quick look at that. So back to the course web page. Here's a forum which covers the whole course, and you're encouraged to post on the forum. No one checks what you're posting, but you can keep in touch with your peers and with people like me and your own tutors. And there are also chapter by chapter forums as well. If we just go back, I'm trying to use the mouse with my wrong hand here. So here's the forum from chapter 1. Not many people posted on that. Somebody was posting about the first question and they received a response. Chapter 2 probably had more posts. Yes, you can see a more active forum there. So you have ways of keeping in touch with each other and with the course team and with the tutors on the course. So we think it's a lovely course. It's a very popular course. Most students are pretty satisfied with it. So if you fancy studying planetary science, this isn't a bad way to progress. Maybe some of you have done the Moons MOOC, which we run in conjunction with FutureLearn. I was the educator on the Moons MOOC. Only runs once a year on FutureLearn, but you can find the Moons course running in a continuous state. It's free learning via OpenLearn. So if you want to dip a toe in the water, go to OpenLearn. Just search OpenLearn and Moons, and you will find the Moons course. You can have a go at some free learning before you begin S283. Okay, that's plenty from me. Goodbye, and if you do sign up for the course, I'll see you in October one way or another. Bye.